In Activity 7, Colored Lighting, students observe how colored light can affect the way colored objects look. They shine colored light on different colored squares of paper and compare the results with those obtained using other methods of mixing colors. You will need the following materials from the kit. Activity Sheet 7, Parts A and B. Colored filters, flashlights with frosted acetate, sheets of white paper, and sheets of colored paper squares. To prepare for the activity, make a copy of Activity Sheet 7, Parts A and B for each student. Separate each sheet of colored paper into squares by tearing along the perforations. Each team of 2 will need a set of 8 color filters, a flashlight, 1 sheet of white paper, and a set of 6 colored paper squares. To begin the activity, hold up a sheet of white paper and ask the students, "What color is this?" What color do you think you will see if I shine light through a red filter onto the paper? Students should say the paper is white and will look red in the light that passes through the red filter. Distribute a copy of Activity Sheet 7, Parts A and B to each student. Hold up a square of green colored paper. Have the class identify the color, then ask, do you think the paper will still look green after you shine light through a red filter onto the paper? Have each student record his or her prediction on the activity sheet. Explain that the color of an object depends not only on what colors of light it reflects, but also on what colors of light shine on it. Divide the class into teams of 2 students each. Give each team 1 sheet of white paper, 1 red filter, 1 flashlight with frosted acetate, 1 square of black paper, and 1 square of green paper. Have students place the sheet of white paper on a flat surface and place the green square next to the black square on the white paper. Darken the room and instruct students to shine light from their flashlights through the red filter onto the green and black squares of paper. Encourage the class to discuss what they observed. In the red light, the green and black squares of paper will be difficult to tell apart. Black pigment absorbs all colors of light, reflects no light, and will always look black no matter what color light is shined on it. Green pigment reflects green light, but because the red filter does not let any green light pass, no green light is reflected back. When no light is reflected by an object, the object looks black. Then ask students, do you think other combinations of color filters and colored paper can make the paper look black? Do you think a piece of colored paper could be made to look a different color by shining colored light on it? Allow students time to share their ideas. Next, distribute the remaining filters and squares of paper so that each team has squares of colored paper and 8 color filters. Have students list on their activity sheets the color combinations of filters and papers they will test, and have them predict what colors they expect to observe with each combination. Then, darken the room and tell the students to resume their experiments. Encourage them to overlap 2 or 3 filters at a time and shine light through them onto the various colors of paper. After the students have finished observing the results of their multi-filter combinations, discuss their results and ask, were there any other combinations that turned the color paper black? Was there a color of paper that did not turn black in any color of light? Students should have observed that green paper looks black in magenta light, red looks black in green or cyan light, and blue looks black in orange light. Some students may get yellow to look black by overlapping filters to form violet or dark blue light. However, white will always reflect whatever colors are shined on it, and so will never look black. Next, ask students, did any of the squares of colored paper ever look the same color as the white sheet of paper they were laying on? When? Help students understand that whenever the light is the same color as the square of paper, that paper square and the white paper background will appear to be the same color. For example, in red light, both the red piece of paper and the white paper look red. Then ask students, could you change the color of one of the squares of paper to something other than black? Explain that shining magenta light on red paper will make it look yellow. In green light, the yellow paper will look green, and in violet light, the yellow paper looks orange. Next, ask students, were you adding colors in this activity or subtracting them? They should observe that the process used was subtractive color mixing. First, some of the colors that make up the white light from the flashlight are removed by the color filter. Then one of three things can happen. The light can be completely reflected by the paper, and the paper will look the same color as the filter. The light can be completely absorbed by the paper, and the paper will look black. Or some of the colors that pass through the filter can be absorbed and some reflected, and the apparent color will be a subtractive mixture of the filter color and the paper color. Finally, let students know that in the next activity, they will be examining printed pictures. Ask each student to bring a black and white and a color picture cut from a magazine or newspaper. To conclude the activity, have students return the flashlights, color filters, and colored paper squares to the kit. The paper squares can be kept in one of the plastic reclosable bags. For science background, reinforcement activities, curriculum connections, and information about the Delta Science Reader, please consult your DSM Teacher's Guide.